So question 3 then, from the specimen paper for the new higher. Paper 2, question 3. Here we have the graph of a quartic function, and it looks like this essentially is asking for the equation of a tangent. But first of all it says, if this is the form of that graph, of that function rather, what are the values of p and q? Just for a mark. Well, you can easily reconstruct the function from its zeros in the graph, from the roots of the equation equal to 0, because that says you've got 1 at x equals 0, 1 at x equals 1, but notice that there's a double root there. There's a double root at x equals 4. So if I was to reconstruct the factors that produce those, that would be an x, that would be an x minus 1, that would be an x minus 4, but it would be down twice. So comparing those together, that means that p, and it is minus minus, should equal 1, and q, and it does say take away, so q should equal 4. Part B. What's the equation of the tangent of the curve when x equals 1? Well, there's x equals 1 there, so it's this line here that we're looking for. Well, I'll need to differentiate to get the gradient. That's no use for differentiating, so I'll have to multiply it all out. So what is f of x? It was x times x minus 1 times x minus 4 squared. We'll just do that in 2 bits. So that's x squared minus x times square the bracket, square the first, x squared, square the last, 16, twice the product, minus 8, x. So that's x to the power 4, I'll just spell it out, minus 8x cubed, just multiplying by x squared, plus 16x squared. And rather than writing it across, I think I'll do the next one underneath in the appropriate columns. So minus x cubed plus 8x squared minus 16x. That's just as an alternative to writing it all out. Finally, we've got x to the 4 minus 9x cubed plus 24x squared minus 16x. Poor. Now we've got this, which of course will give us the y coordinates. If we differentiate it, that'll give us the gradients. So that's multiply by the power, take 1 off the power, multiply by the power, 3 9s are 27, take 1 off, 2, multiply by the power, 2 24s are 48, take 1 off, down to 1, and then just minus 16, the coefficient of the x term. So there's the equation that'll give me the y coordinate, there's the equation that'll give me the gradient. So if it's at x equals 1, I can say this. If x equals 1, that means the gradient will be, so it's just replace 1s into this. Now 1 to any power is just 1, and multiplying by 1 doesn't do anything, so it is just 4 take away 27, but maybe I should show the substitutions. 1 to the power 3, 1 to the power 2, just 1 minus 16. So that's going to be 21 take away 16 is 5, and 4 is 9, so the gradient is 9. And x equals 1, you know already, at x equals 1, the y coordinate was 0. Put it back into that if you like, but if you're going to put it into that, you're better off putting it into this. That's quicker to evaluate, and obviously 1 minus 1 is 0, so it's 0. You can put down, first of all, y minus b equals mx minus a if you like, but essentially you're just going to put in y minus the y coordinate is the gradient times x minus the x coordinate, and I know that does, so that would be the end of the question, but I just prefer to finish it off. 9x minus 9. I just happen to like y equals mx plus c.